I've been buying tools. You want to see? Welcome back to Cloud 42. I'm James. I have been extremely busy lately between the time that I spend at the gym, my day job, and other projects that I've picked up around the house. I have not had as much time in the shop as I would like. However, I have picked up a few tools in preparation for some future projects, and I thought maybe we'd take a look at some of those today. But before I get to that, let me give you an update on my weight loss. This is something that a number of you have been asking about in the comments, and it has been a while since I've given you an update. For those of you who are new to the channel, I have not always looked the way I look today. 14 months ago, I weighed 265 pounds and was almost completely sedentary. If you look back at some of my older videos, you will see that the difference is really dramatic. If you're interested in how I lost the weight, I did a video on that. There's a link up here and you can go check that out. Now, I started from around 265 pounds. I ultimately lost about 80 pounds, got down to about 185. And at that point, I switched over from primarily cardio-focused exercise to barbell strength training. I've been making a lot of progress and really enjoying that. I did intentionally gain about 10 pounds just as I put on muscle mass as I've gained strength. And I feel pretty good about where I am right now. For those of you who are keeping score, I did just test my lifts last week and I squatted 315 pounds, benched 225, and deadlifted 395. I really wanted 405 on the deadlift, but there was just no way that was going to happen on the day. Now, those are not world-class numbers, but I'm pretty happy with them, especially considering I've been doing this less than a year, and I started in my late 40s. So I really couldn't be happier, and at this point, I just could not imagine going back to the way I looked before, or more importantly, the way I felt before. I think that's all that I have to say about that. If you have any questions, comment section down below. Let's go take a look at some tools. This little device is sold as a transistor tester, and there are lots and lots of variants of this. It's commonly referred to as a Mega 328 transistor tester, and these are sold all over eBay and Amazon. Often they're sold as bare boards or bare boards with an acrylic case, or they come in a lot of different form factors. And what it is a device with some test pins here and a microcontroller and a little bit of support circuitry inside, and some very clever firmware that can identify and measure the characteristics of components that are plugged into this socket. So for example, let me grab something that I know what it is. This is a little 2N4403 PNP transistor. Plug that into the first 3 pins of the socket, hit the test button, and it'll probe all the pins with a pattern of test signals and ultimately determine what it thinks this thing is. And this says it's a bipolar junction transistor, PNP. It shows the symbol and the pinout, and it has some measurements like the HFE of 254. I haven't pulled the data sheet on this. I would not trust the HFE measurement or any of this stuff with very much detail. If I really cared, I would look it up, check a data sheet, or use something more accurate. But in terms of just identifying the components, this is an amazing little device. Now, I chose this one. These can be obtained really inexpensively, especially if you get the bare PC board versions of them off of AliExpress or off of eBay, but I opted for one that has a case on it and paid a little bit more just because I like the form factor. I can throw this in a bag, I can throw this on a shelf. I don't have to worry about it getting damaged because it's got a nice little case on it. And that was worth a few extra dollars for me. Let's try a couple of additional components here. This is an unknown 3-terminal device that I just pulled off of a PC board. I'm sure you saw this in a recent video. This is a Heiko desoldering gun, and I picked it up specifically for doing through-hole board repairs, but since I picked it up, I have been ripping components out of every old scrap PC board that I had laying around that I was saving, you know, in case I wanted to reclaim components. So I've got boxes and boxes and boxes of components like this, and that's one of the reasons why I picked this up, because it provides an easy way to identify quickly kind of what I'm dealing with. Now, once I have things sorted and I'm looking for a transistor or something for a particular application, I'll do more careful research, but in terms of quickly sorting out what I have, this is ideal. So I've got this little 3-terminal device, don't know exactly what it is. Hit the test button and we'll see. Now the first time it boots up, you get this additional screen. It takes a little bit longer. Okay, so this says this is a PNP bipolar junction transistor with an HFE of 50. So it's a lower gain, which is what you'd expect from a power device. Let's try something else. Let's try this. I have no idea what this is. I'm assuming it's a very large power MOSFET. Stick that in here. You can see it tests much more quickly if it's already up. And this says it is a big power MOSFET, an NEMOS, and it's got capacitance of the gate, it's got voltage information, and it's got the pinout, 1, 2, 3, gate, source, drain. Let's take a look at a passive component. This is a capacitor. This is one of the capacitors that I pulled out of that DMX amplifier that I repaired a couple videos back. Drop this in here, and this probably provided me with the biggest surprise of anything. I expected it to identify it as a capacitor. There should be about 200 microfarads, and it's identified it as a capacitor, 208.7 microfarads. Gives a little symbol, and this is the thing that surprised me the most. It actually measured the ESR, and it's measured the ESR of this at 1.8 ohms. I had no idea this would measure capacitor ESR. Now this isn't any good for measuring in circuit, but that's impressive. I had no idea it could do that. So that was a pleasant surprise. Let's grab something else here. Here's another 3-terminal device. Not sure what it is. Probably some kind of power transistor. And it is. It's another NEMOS. Let's see, do I have anything else? Well, let's try this. This is a large inductor, large power inductor from a power supply. Let's see if it has any luck identifying that. And yes, it's measured at 0.2 millihenries, so 200 microhenries. No idea. We'll have to measure that with something more accurate and find out. But I actually am impressed that it actually identified this as an inductor and not just a resistor. So I think that's enough. That's you kind of get an idea of what this thing does. I've been actually quite impressed with it. This little ZIF socket can pull out, and you can just plug into the socket here directly if you like, or you can use the ZIF. The ZIF socket is kind of wobbly, so you kind of have to hang on to it. But for the price, and if I've just got a big pile of components to sort, which I do, I've been really impressed with this. In the DMX amplifier repair video, I made a comment that I couldn't measure the ESR of a capacitor because I didn't own an LCR meter, because LCR meters cost money. And that's true, they do. But I decided that I wanted one, so I went ahead and picked one up. This is, I don't even know how you're supposed to pronounce this, DUREE, a D-E-R-E-E LCR meter. This is the DE5000. This is a Japanese-made product, and this is in the kind of $100 price range. And for that price range, what you get with this is impressive. Now, I have used more expensive LCR meters. We have one at work that costs upwards of $10,000. It's a very nice lab grade instrument. And if I had to take, sort of lab grade measurements, I would definitely be interested in something like that. But for something in the home shop, I have found this to be more than adequate. So what an LCR meter is it has a set of bridges inside, and it ultimately sends an AC signal, an AC current through a component, and then measures the complex reactance of that component. in order to measure the capacitance or the inductance. And your typical voltmeter is going to have a capacitance measurement, but it's going to be very limited. You can't control the frequency. It's going to have very limited range and very limited accuracy, whereas this is a purpose-built device just for taking those kinds of measurements. Now, this is actually a 4-wire Kelvin connection. So there's a little slot here for the positive lead of your component and a slot here for the negative lead of your component. In this case, I've got an electrolytic capacitor. I'll just go ahead and press this in here and let it measure it. And what's going on in here is there are two separate wipers that are pinching the wire, and they are connected separately inside the meter. So one of the wipers is actually applying the AC voltage that produces the current through the component, and the other wiper is the measurement point. And so this avoids having any current going through the measurement wire, and so you get a much more accurate measurement. And so in this case, it has automatically adjusted, and it's measuring this at 219 microfarads. However, it's measuring it at 1 kilohertz. I want to change that. So this is 1 kilohertz, 10 kilohertz, 100 kilohertz, 100 hertz, and 120 hertz. And those are the options that you have available. Since this is a capacitor, a low ESR capacitor that's meant for use in a power supply, it's going to be filtering here in North America at 120 hertz. If you were on 50 hertz power, it would be 100. But this is the most accurate measurement for me because this is the way this component will be used. So it's measuring 225 microfarads and is automatically switched to series capacitance measurement. Well, I can switch that automatically, or I can switch it manually and tell it what I want it to measure. So I will switch it into the manual series capacitance mode, and then I can switch, and because I have it not auto-ranging, I can then measure some other parameters. And I'll switch because I want to measure the ESR. So in this case, it's measuring the ESR of this capacitor at 0.1 ohms. And this is one of the replacement capacitors from the DMX amplifier repair. And so I thought it would be interesting to take a look at, okay, this is what a new one's supposed to look like, 1/10 of an ohm. What did the ones I pulled out actually look like? So let's take this out, grab one of these. This is a typical one. And you can see it's measuring about 2 ohms. So 2 ohms is very, very high for a power supply capacitor, but this is by far not the worst. This is one of the ones that was working. There are some others that are far worse. Let me grab another one here. This is the one that had actually failed, and you can see it's measuring much lower capacitance. It should be over 200. It's measuring 124 microfarad. And you can see the series resistance, ESR, is measuring 228 ohms, 0.22, in this case 227.226 K. So this capacitor has just completely failed. I didn't have the ability to measure this when I was actually running this on the board, just because I didn't own an ESR meter yet. I do now. You can see that capacitor is very badly failed. Now this ESR meter came with some other components here. It came with a set of alligator leads. Now these are also 4-wire Kelvin connections. The blades go into these slots here and make contact on both sides. There are actually 2 conductors in each one of these wires right down to the clip. Now a $10,000 ESR meter is going to have insulated clips, so one wire connects to one blade and the other wire connects to the other, so the connection is made right at the component. This isn't quite that good, but the leads are really short, and so it shouldn't matter. There's also a guard here, so we have guard, and these are insulated terminals, which will help avoid interference. So I'll put this on here and measure an inductor. This is just a small power inductor that I grabbed off of a board. So we'll measure that again at 120 hertz and put it back in auto mode. And it's identified this as a 226 microhenry inductor. Now, incidentally, I did measure this inductor on the expensive LCR meter at work, and guess what? It was 226 microhenries. So I've been pretty impressed with the accuracy of this. The other thing that this came with is a set of surface mount tweezers. So again, this is just another device another set of leads with the same Kelvin connections that snap into the meter. And then this is a Kelvin tweezer where the 4 wires come down, 2 of them connect to one tip and 2 of them connect to the other, so that I can take measurements of components on a PC board. So this is one of the boards for my electronic lead screw, and there's a 4.7 microfarad filter capacitor here, and I can just reach down and pinch that and measure. So this is measuring just over 5.1 microfarads, and that's really what you would expect. I haven't measured one out of circuit. It's 4.7, but it's not a high tolerance device. It may actually be that high, but I'm also picking up the other capacitance in the circuit. I've got power planes on top, ground planes on the bottom, so there's definitely some capacitance from the board, but that also may just be the capacitance in the chip, capacitance on the input of the voltage regulator. In circuit, there's other things interfering with that. Let's try a couple of other components on here. There's a 1K resistor right here. It's a very small one. It's an 0603. And there we are, 1.0028K. There's a 10K resistor over here. Let me grab it. $9.2K. Let me grab another one of them in here. These are 5% resistors, so 9.1K. Not bad. And again, there's other stuff in circuit here that's going to be affecting that. So that's an example of how the tweezers work, and I've been pretty impressed. And for just over $100, you can't beat this. There are some other units in the $300 to $400 price range that look pretty good, but for my use, this is great. And it's got lots of other features I haven't even looked at. But just in terms of identifying components and measuring them, I've been very, very pleased with this. If you've been watching my series on the electronic lead screw, then you'll recognize this board. This is the interface board that goes from the microcontroller out to the stepper, servo driver, and the display. And for the display, I'm using a 5-pin right angle header. And to connect to this header, I'm using what's called a DuPont connector. This is a crimp connector with 5 pins in it, and each of the wires is crimped onto a terminal inside, and then these just snap right onto the header. Now, this is really handy. These are very secure because they're crimped. They're very vibration resistant, so this is kind of an ideal solution for this application. But you have to have a special tool to crimp the pins onto the wires. And this is what I've been using to date. This is a really inexpensive crimp tool. This came from Radio Shack back in the day. And it's just got stamped jaws. Let's see if I can get this in focus. It's just got stamped jaws for a couple of different sizes of terminals. And this works if you're just going to do a few, and this has served me well for many years, just doing a few. But especially if you start having to do more than just a couple, or if you're concerned about the quality of the connections, you're much better off with a ratcheting crimp tool. So I decided to go ahead and pick one up. Now you can spend anything you want on ratcheting crimp tools, but I was looking for something true to form that was inexpensive and good enough for my use. And this is what I found. This is actually a set that I picked up off of Amazon with a ratcheting crimp tool, useless manual, and a couple sets of different kinds of connectors. So let's start with the tool. Now, looking at the jaws on this, so overall this is a crimp tool, so it's got a ratchet that goes all the way down and it won't open again until it's completely closed, and that ensures that you have a quality crimp. There's another thing that does is it allows you to ratchet it down until it's holding the terminal in the jaws and it won't fall out while you're working. With the Radio Shack tool, I had to do that by hand. I had to squeeze down and be very, very careful bracing it with my thumb to hold it in place while I found the wire and fit it into the tool, and more often than not I would slip and it would pop out. With the ratchet, you can just bring that down and it'll stay in place. We'll do a demo of that here in a minute. Looking at the jaws, I'm actually pretty pleased with what I see here. I really wasn't sure what to expect on a tool in this price range. Let's see, what did I pay for the whole thing? I think I paid $40 for the tool and all of the crimp connections, which we'll take a look at. These look to me like they're wire EDM, or at least ground. They're not stamped like the Radio Shack tool, and from what I've used it so far, I've been pretty impressed with the quality of crimp that it makes. Let's do one. So this came with a couple of different boxes of different assortments. These are JST XH connectors. If you've done anything with lithium polymer batteries on radio control, cars or airplanes, you'll recognize these. These are the connectors that are typically used for the balancing connectors. We're not going to worry about those. What I'm interested in are the DuPont connectors. And this is a pretty good assortment. It's got some rows of header pins, and it's got a bunch of housings with different numbers of pins. Here are the 5-pin headers, like you saw in that cable assembly. And it goes all the way down to 4, 3, 2, and even single pin headers as well. So we'll just grab one of those, and let me grab a pin. Pins come in strips. So I will just cut one off. So this is what the pins look like individually. They've got the little teeth on them, and I will go ahead and place one in the tool and run it into the first click. And so now it's hard to see that, but the terminal is captured right here in the jaws, and it will not fall out. And so I don't have to worry about that. I can prep my wire. You don't need to take much off the end, just a tiny bit of insulation. And that should be plenty for a DuPont crimp. And then let me just slide this in. And there we have it. One terminal crimped securely on the end. And you can see the insulation is crimped, there's 2 fingers around the insulation, and then the bare part of the wire is crimped in the terminal itself. And then that is ready to go right into a housing. They just snap right in, and then we have a DuPont terminal connection. So you can spend a lot of money on these. You can easily spend $300 on a good crimper. And this is certainly not that class of crimper. This is, you know, a $20 crimper with a couple of $10 assortments of connectors. But for my use, I'm pretty happy with it. I can't complain. Gets the job done without spending a ton of money. When I did the videos showing the VFD upgrade on my lathe, I also showed how to wire up the electrical box. And there were a lot of components in it like this with screw terminals for wire connections. And the way this works is you stick the wire in and you turn the screw to crimp it down. And when I made those connections, I just took the wire, stripped it, and then stuck the stripped wire into the terminal and tightened the screw. And this, of course, works, and it makes a secure connection. The problem is that you're dealing with a bunch of individual strands of wire, and these can very easily fray and end up fraying out the sides. So when you think you're sticking it in here, you're actually peeling off, you know, a strand of copper like this that's now sticking out the side and is a hazard of shorting on adjacent terminals. And so I got a bunch of comments on the video saying that I really should be using ferrules for these. So I decided to go ahead and get the tools so I can do that properly. So I did a bunch of research, and this is what I came up with. This is an inexpensive ferrule crimp tool and a set of ferrules available. I picked these up on Amazon for less than $25. And I was really impressed when I got this and was looking at the crimp. I've used crimp ferrules before that just had a pin with a normal crimp on the back, like an insulated terminal crimp, like you'd see for automotive applications, but this is different. As I close this, take a look at how these jaws come together. They're circular and they crimp down from 4 different sides. So there's a cam action that squeezes the ferrule all the way around down on the wire. So let's put one of these on and let me show you how this works. So I will once again strip the end of my wire. And so there's the stranded end, and then I need to figure out the smallest ferrule that this will fit into. Okay, I think that's about it. The wires just barely fit into that if I take the next size smaller. Oh, yep, it will go in just one size smaller. Got a straight wire here. Okay, so I'll take the blue one here and just very carefully fit all the strands down into there. And then just take the crimp tool and crimp it on. Slide that all the way in, all the way down till it latches, and that is the result. Get a nice solid crimp connection. This is not coming off at all. The wires are squeezed tightly in it, and you can see the texture around the side where the serrated jaws have crushed this down. So then we take the wire once we've got the ferrule on it, and it will just go directly into the terminal here and secure with the screw, just as normal. But with this kind of setup, now we've run no risk of stray wires shorting out connections. And we can also connect and disconnect and reconnect this over and over and over again without any risk to the wire, because these are not going to get bent up, they're not going to get dislodged, we're not going to break off individual conductors. We have a nice solid package. And then the same thing also works on much, much smaller wires, like control wires. Do one of those here with a much smaller ferrule. And the very same tool works to put tiny wires into little tiny ferrules. And again, same thing. Those same things will drop right into the connectors and secure down, just like their big brothers. So every box I do from now on, I'm going to do these. I really like them because they're nice and neat. The wires don't fray and they're much easier to manage. So for 25 bucks, I thought that was a steal. Okay, the last tool that I want to show you today is this industrial label maker. This is a Dymo Rhino 4200. And I've had a label maker that I've used for years. I've had one of these Dymo Letra tags, but it uses 1/2" tape, and that's the largest that it supports. And while you can get 2 lines of text on it, it ends up being so small that it's barely usable. And what I wanted to do is label my electronics drawers like these with information about the components that are in it. And a 3/4 inch wide label with 3 lines of text is just perfect for that. And that's something that this label maker does easily. So it uses several different sizes and types of materials. The one that I use the most is this 3/4 inch nylon. And that turns out to be perfect for labeling drawers like this. But that's not the main reason why I bought this. The main reason why I bought this is for labeling wires and cables. So for example, this crimp connector that we just made to go into a DIN terminal block, when you get a whole bunch of these in a box, it's hard to keep track of where things are, and I wanted to be able to label the individual wires. And this label maker does that easily. So I'll power it on here, and it wants to know the width of the label that I just put in it. I put in 3/4 inch. And let's say I want to label this, that's fine, phase 1. So this is the label, and I will say that I want to do a wire and cable label, and it'll want to know what size wire I'm using. So you can set this for Cat5 cable, you can set it for coax, you can set it for big stuff. I'm going to set it for AWG 3+ because this is 12 AWG wire. Okay, and then print. And what this does is it prints a small label with the text across the label printed several times. And so then what you can do with this once I peel off the backing, so you can just wrap this around the wire. And once you have that wrapped around the wire, you have a nice, neat little label that's right on the wire that has the writing clearly legible. So then if I stick this in the terminal block, the writing is very clearly legible, and if I've got this whole thing full of wires, I can very easily see what each one is. It'll also do flag labels. Let me swap out for some 1/2" material. Tell it that it's 1/2", and say that I want to do a flag. And flag type, and then it wants to know the flag length. And I'll just say, let's just do a 3/4 inch flag. Okay, and print. And then that prints a label that's designed to be folded in half and wrapped around the wire. Let's see if I can make these match up. And then you get a nice little flag that wraps around the wire, and this material is set up so that it absolutely will not peel apart. Once it's on there, it's permanent. These are very, very durable. But these are not the only tricks that this has. It'll also print on heat shrink material. So these are 3 different sizes of heat shrink tubing. We've got 1/4 inch, 3/8, and 1/2 inch heat shrink tubing, and this will actually print directly on it. So if I pull this out, drop in another wire here, drop in this cartridge, tell it that this is 3/8 inch material, and then I can just do a standard label. That's set to size of 324 point. I'm going to go a little bit smaller. Let's go 12 and print. And this has now produced a piece of heat shrink tubing with text printed on it. So I can take this little piece of heat shrink tubing, slip it around a wire, and shrink it on. And that gives us a very nice, very neat, very solid and durable label. So that gives us 3 options. We can make a label that wraps around a wire, which is really handy if the wire already has a connector on the end. We can do a flag that we just tape on, which is handy for bigger cables or places where you need larger text. And we have the ultra durable heat shrink tubing that you can just slip around the wire. Now, of course, you can only do this when there's no connector on the end, or if you're using a size of tubing that will fit over the connector. But all in all, I am very happy with this label maker, and this is going to make my electrical box installations a lot neater and a lot easier to maintain long term. This video has been a little different from what I normally do on this channel. Did you like it? You're still here. Hopefully we'll get back to some regular project videos soon. But in the meantime, if you enjoyed this video, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.